Welcome, my name is Jerry Tsunerine, and today's lesson will look at how can I use what I know about fractions to solve real-world area problems. Before we get into today's lesson, we're going to review a few concepts, such as multiplying fractions and also converting improper fractions into a mixed number. So what we're going to do is when we're doing multiplying fractions, we want to convert given fractions to improper fractions. So in other words, we don't want to have a whole number on the outside. We would just want to have a numerator and denominator. So when we're converting our mixed numbers to improper fractions, what we're going to be doing is we take the given denominator and we write it across. And in order to find our new numerator, what we're going to do is we're going to multiply the denominator by the whole number, and we're going to add the numerator to get our number on the top. So in this example, we're going to do 3 times 5, which is 15, plus 1 is 16, and our new improper fraction will be 16 over 3. We do the same thing over here. So if we're converting 2 2/3 into an improper fraction, we keep the 3 as the denominator, and we're going to multiply 3 times 2, which is 6, plus 2 gives us 8, giving us an improper fraction of 8 over 3. So that's how you convert a fraction into an improper fraction. Then we're going to multiply across, and then we're going to turn it back into a mixed number. So in this example, we multiply 16 over 3 times 8 over 3 to give us 128 over 9. Now we're going to look at how do we convert 128 over 9 into 14 2/9. So when we're converting an improper fraction into a mixed number, to get the whole number, we're going to divide the numerator by the denominator. So here when we divide 9 into 128, 9 goes into 128 14 times with a remainder with some numbers left over, which is 2. The 2 is going to be very important for the numerator. So the 14 is our whole number. The 2 will go in the place of the numerator. And then lastly, the denominator does not change, so we don't have to do any work there. So here, that's how you convert an improper fraction into a mixed number. So now we're going to go into our first problem. Problem 1. The length of a flower bed is 4 times as long as its width. If the width is 3/8 meter, what is the area? So we want students to pause the video, think about reading the problem several times, take out the important information, possibly draw a picture which will help them or may help them, and then think about how they would figure out other missing information to get to arrive at the answer. So on the next slide, we've provided some guidance. So when looking at the steps, it's important to identify and name what is needed in order to get to the answer. So in the problem, we see that the width is given, however, we don't know what the length is, and we don't know what the area is. So what we can first do is find the length. So we know in the problem that the length is 4 times the width. So here, I highlighted it in yellow. We can go down to the yellow section and see how do we calculate that. So that we indicated the width is 3/8. We're going to multiply that by 4, and we're going to turn it into a fraction, 4 into put it over 1, and we're going to multiply across. 3 times 4 gives us 12. 8 times 1 gives us 8. After that, we can simplify 12 over 8 because there's a number that divides into both the numbers evenly, and we're going to divide by the GCF. The GCF stands for greatest common factor. So in other words, what we're going to do is we're going to find the factors of 8, we're going to find the factors of 12, and see what is the largest number that they both share. So for students, sometimes they think of 2, but however, we want them to think of 4 is greater than 2. So it's very a helpful hint for them is to list it out so that they can see the different values and to check themselves. After we determine 4 is our GCF, we're going to divide the top and bottom by 4, and we get 3/2. The last step is to find the area. So we're going to multiply the width times length, and here is the indicated values here. And what we find is 3 over 2 times 3 over 8 gives us 9 over 16. So therefore, the area of the flower bed is 9/16 meters squared. And it's important when we're dealing with area that our units is squared. So since we have meters, we put meters squared. Now we're ready to look at our next problem. Problem number 2. Miss Johnson grows herbs in her square plot. Her basal plot measures 5/8 of a yard on each side. Find the total area of the basal plot. Here in this problem, we want students to understand the misconceptions that even though we have one side that's given and it's a square, we also want them to know that a square has all sides are the same. So if we have 5/8 here, we want them to figure out the other side to then figure out the total area. So here, what we want to do is we want students to work through this, and on the next slide, we have provided guidance on how to work through this problem. Okay, so when we're finding the area, just previously mentioned, a square means that all sides are the same. So what we're going to be doing is, since we know that one side is 5/8, the other side is also 5/8, and we can multiply that across, and 5 times 5 gives us 25, 8 times 8 is 64. Here we do not need to take the GCF, but we can have students take the GCF and see if there's a number that's common between the numerator and denominator. In this case, there's no value, and we'll put the units as yards squared because we are finding the area. Last but not least, we're going to go into our final question. So here, Janet bought 5 pieces of fabric. Each fabric is 2 1/4 feet wide and a length of 3 1/2 to make a curtain. We want to do two things. We want to find the area of one piece of the fabric and the total area of all the pieces of fabric Janet has. So we want students to figure this out, think about key information, reading the story a few times, and see how they can work through the problem. Okay, we're going to go on to our next slide. So when we're finding the area of one piece of fabric, it's important that we can convert the two values, the length and the width, and convert it into improper fractions. After we do that, we multiply across. So here we convert it through our process, then we're going to multiply across. 7 times 9 gives us 63, and 2 times 4 gives us 8. We go through the process of converting an improper fraction to a mixed number so that we have the total area given here. And just as a reminder, here's some extra guidance on how to calculate the whole number and the numerator. So finally, our final answer would be each piece of fabric has an area of 7 7/8 feet squared. Now for our second part of the problem, what is the total area of all the pieces of fabric Janet has? So since we know one fabric is 7 7/8, we just need to multiply that by the 5. So when we're multiplying it, it would be easy to convert the 7 7/8 back into an improper fraction so we can multiply it easily. And when we do this, we multiply across, and then when we do that, we find that we have an improper fraction, and we go through the same process of converting an improper fraction into a mixed number. When we do that, we find that Janet's total area of fabric is 39 3/8 feet squared. Now we're ready to move on to our summarization. All right, to summarize, how can I use what I know about fractions to solve real-world area problems? So we want to practice changing improper fractions into mixed numbers and vice versa. We also want to practice multiplying fractions and also understand GCF to simplify a fraction when given the opportunity to do so. Here are some examples that show each of the process. So hopefully this was helpful. Have a great day.